Alright everyone, thanks for watching. So I'm going to do these videos along with what we've done in class to talk about chapter 1 and 2. This will be the first one where we're just going to kind of understand what these rational numbers are. So that's what we're learning. We're learning about rational numbers. Section 1 is a little bit about that. Section 2 is adding integers, adding rational numbers, subtracting. So basically this is just adding and subtracting. And to this we're adding numbers on the negative side. So that's what we're going to learn about how that is. But that's basically what you're learning is how to add, subtract, multiply, and divide. All the numbers you already know how to do plus negative numbers. So let's look at some of those numbers. Okay, so whole numbers are what you're used to. Whole numbers start at 0 and they go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So whole numbers are your counting numbers and they just go on forever, okay? Integers, on the other hand, include those negatives, or what they say is the opposite. So you almost have to start in the middle here at 0, and you have to say that this one's 1. So integers not only include 1 and 2 and 3 and 4 and 5, but they also include their opposites. The opposite of 1 is negative 1. The opposite of 2 is negative 2. The opposite of 3 is negative 3. And so on. Okay? So that's your group of integers. So integers include, actually whole numbers I do not believe to include 0. So, but either way, I don't think that's terribly important. Integers do include 0 and the negative numbers. Rational numbers are all of the numbers, but it also is going to include the things in between 1 and 2. Like, so in between 1 and 2, 2 and 3, 3 and 4, even 0 and 1, and 0 and negative 1 are these little things called fractions, okay? And fractions can be written as decimals, but they are not different. In fact, every number can be written as either a fraction or a decimal. Let me give you an example. The number 2, that is how you write it as a whole number or an integer. You can also write 2 as 2 over 1. That is a fraction, the fraction version of 2 over 1. I could even write as a fraction, I could even write as an equivalent fraction 4 over 2. Guess what? 4 divided by 2 is just 2, so that's also 2. Okay, or as a decimal, I would write this as 2 wholes and 0.0. Okay, so on my number line here, let's go ahead and give you something here. So again, rational numbers include the positives and the negatives. So let's use, what do you want, is halves? Let's use halves. So if this is 1/2, this would be 2 halves, which is also 1. This would be 3 halves, which is also 1 and 1/2. And then the opposites. So this would be negative 1/2. This would be negative 2 halves, and this would be negative 3 halves. So, and we're going to get into this more, so don't worry. But rational numbers are basically include integers, and they include whole numbers, and this fractions and decimals. So let's talk about that. So what is a fraction? Let's talk about fractions for a second. So this here on the very left is 1 whole. Okay, I can write that like this. I can write that as 1 over 1. Or I can write that as 1.0. Now, if I divide this up into 2 parts, if I just make this division right here, I have just divided this up. Now, I have 2 over 2, right? So 2 out of my 2, assuming this whole thing was shaded in. Or actually, I have, if you want to talk about just the green part, I have 1 over 2, okay? But I'm just talking about if this whole thing were green. I should have made it that way. Sorry. I'm not going to change it. We're going to move forward. Okay, so this thing would be, let's assume this whole thing's shaded in. This would be 2. This one over here is 2 parts total and 2 parts shaded in and 3 parts total. 2 parts shaded in, there's 1, 2, 3 total. All right. So now, last one is, oh, sorry, my pen messed up. Okay, the last one is 4/8. There's 1, 2, 3, 4 parts shaded in and 4 parts not shaded in for a total of 8 divisions. So if we divided up this one whole, so this is the key. We still have one whole circle, right? All these circles are meant to be the same size. They're all one whole thing to begin with. This one whole has been divided into 2. That's what the denominator means. This one whole has been divided into 3. That's why the denominator is 3. This one whole has been divided into eighths, which is why this is eighths. And now how much of it are we talking about? How much is shaded in? 1 part, 2 parts, 4 parts. Now here's a funny thing. What if you just look at this from the whole perspective? How much of this one right here is shaded in? Hopefully you've thought 1/2. So that is a simplified or equivalent fraction, right? And we got that by dividing the top and the bottom by the least common, the greatest common factor, right? So now, hopefully you're understanding that the whole point of this is that this is one whole, and if I divide it like this, that is still one whole, but I've now divided it into half. I've divided it into fourths, etc. So we're going to keep playing with this. It doesn't have to be a circle, okay? You could divide any of these shapes up, like this triangle here. What fraction does this represent? Well, it's a whole triangle, and exactly it's been divided into 2 parts. So we know that the 2 goes on the bottom. Well, how many of those two parts is filled in? 1. Okay, let's look at one more. What about this one? This one looks in. No, we did circles. Let's do this one. Okay, this is a rectangle. Doesn't matter. It has 4 parts of the whole, and 1 is shaded in, right? So you could go through and fill this in. Equivalent fractions. Okay, let's talk about that. So let's look at just the top left one here. Okay, so this is a one whole, right? The whole thing is filled in. And 2, it's divided into 2, so that's my bottom number. And both of them are filled in, so 2/2. The whole thing is filled in. That is one whole. Over here, it's still one whole. It's just been divided into 4 pieces, and 4 of them are shaded in. Okay? Down here, this is divided into 8 pieces. That's why it's an 8. And 4 of the 8 are divided in half. That equals, this is the same thing as having this whole, right? So half of just this whole top half is yellow, right? While in this one, the left half is yellow, which if I flipped it upside down would be the top. But either way, half of it is shaded in, half it's shaded in here. So this is divided into 2 parts, and 1 of them is filled in. Okay, last one. Let's look at this one. So this one is 1, 2, 3, 4 pieces divided up and 3 are shaded in, which is the same thing. If you look at these, I really wish they would have put these in the same area, but you can see that this little white area is the same size as this white area. And what they're trying to show you here is that 3/4 is the same thing as 1, 2, 3, 4, 5, 6 out of 8. That's another way to look at a fraction. 6 out of 8 are shaded in. Okay? All right. So let's just talk about improper fractions. And I'm actually going to erase this. We're not ready to look at that. Okay. So improper fractions. So an improper fraction, so all the fractions we've been talking about, the top number was smaller than the bottom. As far as decimals go, that means that 0 is the whole and 0.5 would be the fraction. Okay, hopefully you guys all know that 1/2 is 0.5. We would get that by dividing the top number by the bottom number. 1 divided by 2 is equal to, well, that can't go in there, so, and that's how you always figure out how to make a fraction into a decimal. You divide. The top number goes into the bottom. Always remember FTT. The first number, which would be 1 divided by 2, 1 over 2, and that goes in the trap. So FTT is something I taught myself a long time ago, and it just basically means the first number, the top number, go in the trap so that you divide, so you know which one goes into the trap when you divide, and it also goes in your calculator. So I would put 1, division symbol 2, 1, division symbol 2. By the way, this means division if you haven't figured that out yet. 1 divided by 2, and then when I actually do it longhand, that's how it works. Okay, so let's talk about this here again, this improper fraction. So what's happened with this improper fraction is the top number is not the small number. So I have more parts than I do whole. I have more parts shaded in than my divisions, right? So if I look at these circles, what are they divided into? They're divided into 4 parts, right? So this one has 4, this one has 4, and this one has 4, even though it's cut off, sorry. So it's divided into 4, but I have more than 4/4, right? This right here is 4/4. This one here is 4/4. This one here is 1/4. So if you add those together, you end up with an improper fraction of 9/4. 4 plus 4 is 8 plus 1 is 9. So anytime the number on top is greater than the number on the bottom, so 12 over 5, 12 is bigger than 5. Therefore, I have an improper